Hello everyone, this is lesson 10.3, Apply Properties of Chords. Today we're going to use properties of chords in circles. There are 4 different theorems that we'll talk about and learn how to apply those. So the first thing to recall is the definition of a chord. A chord is a segment with endpoints on the circle. A chord can also be a diameter if it goes through the center of the circle. So a chord is also like the segment version of a secant line, where a secant line goes through the circle and a tangent line only touches the circle at one point. Okay, so here, another thing about chords that we didn't really talk about yet is that a chord divides the circle into 2 arcs. So if it goes through the diameter, or if the chord is the diameter, then it'll just intersect it with 2 semicircles. But other than that, a chord will always make a minor arc and then a major arc. Okay, so that's going to be important as we discuss these next 4 concepts. So the first one is, I'm going to call this one 10.3a, because on the next page we're going to go through some examples and identify which property we're talking about. So I'm sorry, these are not theorems, but they're just properties. So in the same circle or in congruent circles, 2 minor arcs are congruent if and only if their corresponding chords are congruent. So we're talking about arc AB and arc CD. If they are congruent, then the chords that create those 2 arcs are congruent. So, and then the opposite, if and only if, means you can go in either direction. Okay, so if arc AB is congruent to arc CD, or I guess we'll just go in the same order, DC, if and only if arc A or chord AB, which is a segment, is congruent to chord DC. And then this next one we'll call 10.3b. If one chord is a perpendicular bisector of another chord, so here, if SQ is a perpendicular bisector of, we'll assume this is TR, then the first chord is a diameter. So SQ would be the diameter in this case. There's a way to prove that, which we'll either do in this example or you'll do in the Edulastic. I think you do it in the Edulastic. So if QS is perpendicular bisector of TR, then QS is a diameter. Which means that the center is somewhere along diameter SQ, QS. All right, 10.3b. Sorry, C. If a diameter of a circle is perpendicular to a chord, then it bisects the chord and its arc. So notice back here, this doesn't really say anything about the arc, but this does. So if a diameter of a circle is perpendicular to another chord, so here e.g. perpendicular to FT, then it bisects the chord, so that means FH is congruent to DH, and its arc. So that also means that FG would be congruent to GD, arc GD. All right, so this measure here is 90 degrees, but this measure isn't 90 degrees, this arc. Obviously you can see that it wouldn't be 90 degrees, but the reason it's not is because this is not a central angle. Central angle that is equal to the arc measure, but if it's not a central angle, then it's something else, and we will discuss that in a different lesson. Okay, so right now we're just talking about the chords and their properties. Okay, so let's say FH congruent to HG, and arc FG is congruent to arc GD. All right, and then the last one, 10.3D. In the same circle or in congruent circles, 2 chords are congruent if and only if they are equidistant from the center. So here, AB is congruent to CD because they are both equidistant from the center. How do I know? Because it's perpendicular, showing that that would be the shortest distance. Okay, so what are we writing here? CD, the chord CD is congruent to AB if and only if FE is congruent to GE. And I guess you could have written that the other way around, but it doesn't matter. And remember that you can go both directions. So if they're equidistant from the center, so if that's congruent to that, and it's perpendicular, so it is important to show the perpendicular symbol, because that just means that you're talking about the shortest distance. Then the two chords are congruent. All right, so let's talk about some examples here. So find the length of the given chord. So here, if you look at your theorems, what theorem are we talking about here? We're talking about 10.3a, b, c, or d. So here, this would be talking about 10.3a, at least in example 1. So that's saying that if the arcs are congruent, then the chords themselves are congruent. So if this is 9, then AB is 9. All right, this one here. So this is showing a diameter that's perpendicular to a chord. So if the diameter is perpendicular to a chord, then it bisects the chord in its arc. So if it bisects the chord, this is 10.3c. Then this is also SQ. This is also 11, so then the whole thing would be 22. Okay. And then another little tidbit here to explain is here, if you drew the radius, TQ, and TQ, and you know that the radius is the same, and you know that these are both perpendicular, and you know that these share, so this would be hypotenuse leg theorem, so then you know that these two are congruent, okay, by hypotenuse leg congruence theorem for triangles. Okay, so that's how we can tell that it also is bisecting. Okay. Number 3, is PR a diameter of the circle? Explain. So PR, it says it's perpendicular to SQ, but we need to know if it's a perpendicular bisector. So here, we're not going to be able to say if it is or not. So no, we don't know if it bisects QS. Sorry for my sloppy handwriting. Okay, and that would be 10.3b. 4a. So here you have a chord. It's bisecting, but you don't know if it's perpendicular. Okay, so no, we don't know if it's perpendicular. And then if SQ, thinking about the same triangle or same setup here, if SQ, this chord is 16, and the diameter of the circle is 20, how far from the center of the circle is SQ? Okay, so they're saying if this is 16 and the diameter is 20, how far from the center of the circle? I guess we're assuming that this is a diameter now. So if the whole diameter is 20, then the radius must be 10. Okay, how far from the center of the circle is SQ? So we're saying how far is this part away from the center? So if you were to draw a triangle here, we're looking for this length here. Well, wouldn't that be 10? No, that's not the radius. The whole thing from this point to R would be the radius, but this is only part of the radius. I do know that this is the radius though, so that's 10. So then you've got this right triangle here, and we're assuming for this question, I'm drawing the diagram over here, that it is a diameter. Okay, well, they told us it's a diameter, so we know it's perpendicular. So we have this right triangle. So we can find this length here, this distance, by using the Pythagorean theorem. We could say x squared plus 8 squared equals 10 squared. Okay, and then if you remember the 3, 4, 5 right triangle, you're just doubling it. So this would be 6, but if you didn't figure that out, let's solve it. So this would be 64, this would be 100. You subtract 64 over, you get 36. So So then if you take the square root of 36, you get 6. X equals 6. All right, so that's kind of an interesting question. All right, find the missing arc measures. Okay, so the measure of arc TU. Well, they're saying that this chord is the same as TU, so that means whatever the measure of arc SR is, that's going to be the measure of arc TU. Okay, now how do you know the measure of arc SR? Well, its central angle is 85, so this is going to be 85, so that means the measure of arc TU will be 85. And this would be 10.3a. The measure of arc AC. So from here to here. Well, they're saying that this arc measure is 100, and since these two are being divided by chords that are congruent, that means this arc is congruent to that arc by 10.3a again. So if you take 360 and subtract it from 100, you get 260. So if you divide that in two congruent pieces, you get 130. Number 7, the measure of arc HK. So HK, so we've got a diameter here that's perpendicular. So it's also going to be a bisector that bisects the chord and its arc. So that means this will also be 55. So HK, you got to be careful what you're being asked to find. It would be double that and 110. And this one is going to be 10.3c. Okay, find the value of x. So this one looks like 10.3d because it's showing two chords that are equidistant and perpendicular to the center point. So that means that they're going to be the same. So to set up an equation, we would just set these two guys equal to each other. All right, solve this equation, subtract the x over and add the 11. 2x equals 20, and x is 10. And just set to find the value of x. All right, this one looks like it's 10.3a, because they're saying if the arcs are congruent, then the corresponding chords are congruent. So x squared plus 4x minus 1 equals 3x plus 11. We've got a quadratic equation on our hands. Let's subtract the 3x and the 11, and we would get x squared plus x minus 12. Right, and let's factor this. So it would be factors of 12 that add to 1, 3 and 4, right? But if I want positive 1 in the middle, I would have to make the 3 negative and the 4 positive. Okay, so that would give us answers of 3 and negative 4. Would both of those work? No, the negative 4 is not going to work because if I plug in negative 4 for x up here, I get negative 12 plus 11, which would be negative 1. So that's not going to work, so 3 is going to be our answer. Okay, so 3 is your final answer for that question. All right, and then how about this one? So this is saying, okay, so this is a diameter, it's perpendicular to this chord, so that means it's perpendicular bisector and it bisects the arc, so this is also going to be 80 minus x, and then by process of elimination, we can figure out that if this is 5x, this is also going to be 5x. Or you could do 80 minus x plus 5x equals 180. So these two are going to add up to 180. So 5x plus 80 minus x equals 180. Simplify. 4x equals 100. X is 25. And then last question here. This one's really important, so make sure you're paying attention. Suppose the radius of a circle is 17 inches. Okay, let's draw a circle. The radius is 17. And a chord is 30 inches. So I'm going to draw a chord over here. How about let's call it chord AB, and let's call the center point C. So this is 30 inches long. Find the distance from the center of the circle to the chord. So we're trying to find the shortest distance here. So if I were to extend the radius and draw the diameter, I'm asking to find this little segment right here. So how do we find that? Well, let's draw in the radius over here from A to C. And then if we have that, by theorem 10.3c, we know that if this is a diameter, then the way I'm drawing this, if this is the shortest distance, then it must be perpendicular to the chord. So then we can use this theorem to say that we've got a right triangle on our hands. So whatever this is, it must be congruent to that. So if the whole thing is 30, then this is 15. Okay, then this is also 17 because that's the radius. Okay, so this is making sense so far because the radius, which is our hypotenuse of this circle, is the longest side. So we're just going to find this little part right here, that little part. So let's set it up Pythagorean theorem. X squared plus 15 squared equals 17 squared. 15 squared is 225. And what's 17 squared? Oh, I don't know. 17 squared. 289. So if I subtract 289 and then minus 225, I get 64. So if x squared equals 64, then x equals 8. Okay, so that's an interesting question that you will definitely see in the Elastic. But that is the end of this lesson, and I hope you guys have a great day.